All right, hello, Algebra 2 students. This is Mr. Bear, and I am going to talk to you today about how to work with measures of center and spread. This activity would have started with us doing a class survey about how many hours a week do high school students in our state watch something on their devices. So what we're going to have to do is we're just going to make up some data. So let's say I took a class of 10, okay? And let's say that one person said they watch maybe 1 hour of streaming. Another student said they watch 2 hours a week. Another couple of students said they watch 3 hours. Another student said 4. We had about 2 people that said 5. We had 4 people that said 6. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops, I got 11 here. Let's say we had one say 7 and one that said 15. Okay, so I've changed the data. It's not going to be out of 10. It's going to be out of 12. Actually, 13. Okay, whatever. Actually, let's make it, let's add another 1 at the front. Let's just do 14. Okay, so 14 students. Okay. All right, so we're going to make a dot plot for these. So to make a dot plot, we're just going to make a number line, and we're going to go from 1 to 15. There we go. I got them all fit in there. All right, so then we just number our number line, and we put dots to correspond with each data point. So I had a 1 and a 1 and a 2 and a couple of 3s and a 4 and a couple of 5s. And we had 4 6s. We had a 7 and we had a 15. Okay, so that is our dot plot. And so now what we are asked to do is calculate the mean, the median, and the mode. Mean is where you add up the values, and then you're going to divide by the number of values that you added up. Okay, so for this example, I would add 1 plus 1 plus 2 plus 3 plus 3 plus 4 plus 5, 5, 6, 6, 6, 6, 7, 15. So to go ahead and take your calculators, let's just do this real fast. Let's see, 6 plus 4, 10, 24, 7, and 15. All right, add all those up, I get 70. We're going to divide that by 14. 70 divided by 14 is exactly 5. So our mean is 5. That's pretty cool. For our median, what we want to do is we want to look for the middle value, but the data must be in order. Okay. Let's go ahead and see what our middle value is here. So the way I usually do this is I kind of use the cross-off method, where I kind of take the first and the last off. Okay, you all have done this before, I hope. And when I look at this, I have 2 numbers in the middle. So you would take 5 plus 5 divided by 2. So that's 10 divided by 2. So we get a median of 5. Okay. For the mode is just the most frequent value. So which one did we have the most of? In this case, it was 6. All right, so now we have our mean, our median, and our mode. Now it says we forgot to add one person to the data set. They watch 60 hours a week for Netflix. All right, so we're going to calculate the new mean and the new median. So originally when we did our mean, we had 70 divided by 14. Well, we're adding 60 to this, and then we add 1 more to our denominator. So that gives us 130 divided by 15. Let's see what that gives us. So 130 divided by 15, we get 8.7 approximately. So our mean went from 5 to 8.7. All right, for the median, we're going to add on that 60 at the end. And I'll do this in black, actually. All right, so we would do our cross-off method. And in this case, we just had one number in the middle, so the new median is still 5, okay? Now, of those values that we just did, which one changed more? Was it the mean or the median? So the mean changed more. And that's because that 60, we're going to call this an outlier. And we're going to say that mean is not resistant to outliers. What that means is that your mean is going to be affected by outliers, median not so much. Sometimes the median might change, but for the most part, the median does not change. Okay, so now let's summarize this. So when we do mean, we're finding the average. So you're going to add up the values, and you're going to divide by the number of values. Okay? For the median, you're going to order your numbers, small to large. Find the middle. If two values are in the middle, add and divide by 2. Okay? Remember, if this is going too fast for you, please pause the video to catch up. All right, mode is the most frequent value. All right, so think of that as the mode is the most. Okay? Now, the effects of outliers. Outlier is an extremely large or small value compared to the others. Okay? Mean, higher impact because mean is not resistant to outliers. Okay? Median, not much impact by an outlier. And the reason for that is because the median deals with the middle value. So those numbers that are out on the far ends really aren't going to impact where the middle is. Okay. So now, if the mean number of hours watched was 5 hours, does that mean that each of the 6 students must have each watched 5 hours? No. One could watch 4 hours while another could watch 6 hours. 4 plus 6 divided by 2 would still give you a mean of 5. All right, so just because the mean is 5 doesn't mean that each student watched for 5 hours. All right, let's say that we had 6 students and these were their numbers of hours that they watched TV. We want to calculate the range. Range is just high minus low. So in this case, we would do 8 minus 2, which is 6. Okay? Sometimes it might be necessary to understand how spread the data is from the mean. Okay? What that is called is standard deviation. The best way to look at, or the best way to do this is look at the data as a dot plot and see how the dots are spread out from the mean. Okay? So, important ideas. So, we call the range the distance from the max to the min. So, that's just that high minus low. Oh, I had that right here. Okay? And then the standard deviation. Standard deviation is the average distance from the mean. Okay, so the smaller the standard deviation, the more closer the dots are to the middle. So if we look at these examples, for a low standard deviation, notice that these dots are very centered in the middle. Whereas for the high standard deviation, here's our middle, but the dots are far away. So the further away the dots are from the middle, the higher the standard deviation. All right, so let's look at some examples. All right, so we have 3 data sets here, and we want to first compare the mean of data set A with the mean of data set C. All right, the mean of data set A is going to be 2. The mean of data set C is going to be 12. Okay, I'm not going to calculate those, but you would just add up all of the values of each dot and then divide by how many dots you have. All right, so in this case, the mean of data set A is less than the mean of data set C. All right, now let's look at the standard deviation of data set A. Data set A and data set C have the same spread. So you can tell that the dots on data set A and the dots on data set C are exactly the same distance away from the middle. So those standard deviations are going to be equal. Okay? Remember, standard deviation is talking about the distance from the middle. It's not talking about what that value is. Okay? The next one says standard deviation of set A is what compared to set C? Okay. Oh, you know what? I just realized what I answered on this last one was actually for the next one. I'm sorry. Please don't hate me. Let me go back, okay? I made that mistake there. So data set A versus data set B. I'm sorry, I was looking at data set A and data set C. So data set A and data set B. On data set B, I noticed that I have more dots further away from the middle compared to data set A. So the standard deviation for data set A is less than that of data set B. And that's because data set B has more dots far from middle. Okay? Now, going back to what I was trying to say before, when we look at data set A versus data set C, A and C have the exact same spread, so same spread, which means their standard deviations are equal. Okay? The range of data set B has a high value of 4 and a low value of 0, so 4 minus 0 is 4. For data set C, we take 14 minus 10, which is 4, so those ranges are equal. Okay. All right, let's look at these ones. Let's say we had this data set here and we add a value of 12. Okay, so let's say 12 is down here and we add that on there. Whoops, I don't know what just happened there, but that's weird. Let me fix that. I don't know how that jumped like that. That's so weird. All right. Now, actually, I think... technical difficulties, they are real. Sorry. Anyway, we're trying to go out to 12 here. And we add a dot there. How will this affect the mean? Well, mean rises. That's because we have a high outlier. All right, if we add that value of a 12 to this data plot, how will that affect the standard deviation? Well, in this case, because that dot is exactly the middle, what we're going to say is that the standard deviation decreases. distance from the mean is 0. So we have so that's one more data value, but it's not any further from the mean. So therefore, it must decrease the standard deviation. We have even less dots far away from the middle. All right, so now let's check in for understanding. Let's see how well we know what to do here. All right, so we have a curious math student wonders if the sizes of families are different for students than for teachers. She started with a random sample of 14 students and asked them how many siblings are in their family. And here are their results. Okay, so we want to figure out the mean. So for the mean, we need to take the number of siblings and multiply it by the frequency. So that means we have 3 people with 0 siblings, so that's still 0 siblings in the count. 1 sibling for 4 people, so that's 4. 2 times 3 gives me 6. 3 times 2 gives me 6. 4 times 1 gives me 4. And 5 times 1 gives me 5. If I add all of this up, this tells me how many total siblings there are. So 9 plus 6 is 15, 21, 25. And then we're going to add up the frequencies to figure out what our denominator is. So the frequencies tell us how many people were asked. We should know that to be 14. So our mean is going to be 25 divided by 14. So we're going to take a calculator and we'll divide that out. And we get 1.8 siblings, okay? All right, for the median, best way to do this is probably just list these out. So 3 people said 0 siblings. Let's see, 4 people said 1 sibling. 3 people said 2 siblings. 2 people said 3 siblings. 1 person said 4 siblings. And 1 person said 5 siblings, okay? So now we're trying to find our middle value because it's median. So I'm going to use the cross-off method. And in this situation, I have 2 numbers in the middle, so 1 plus 2 divided by 2, we get 1.5. All right, so our median is 1.5. Our mean was 1.8. The mode, well, the mode is just simply which one of these occurred the most often. So my frequency that is highest is 4, which means the number of siblings for that is 1. Okay? Oh, okay, never mind. All right, now let's look at this one. It says she also took a random sample of 9 teachers and asked them how many siblings are in their family. Here were the results. What is the mean number of siblings for the teacher? Let's see, we have 2 people that said 0, 2 people that said 1, 1 person that said 2, 1 that said 3, 1 that said 4, 1 that said 5, and 1 that said 8. So we're going to add those numbers up. 0 plus 2 plus 2, 4 plus 3 is 7, 8, 9, 10, 11, 16, 24 divided by 9. So we have 9 dots. 24 divided by 9 is 2.7. Okay. For the median, what we're going to do is just list those numbers out. So we have 0, 0, 1, 1, 2, 3, 4, 5, 8. And then I cross off the first and last. And 2 is our median. So this time we didn't have to add them up and divide by 2. Next one says the teacher with 8 siblings actually has 16. If we were to correct this in the data set, how would that affect the mean and the median? Well, the mean will increase because we have a high outlier. The median stays the same. And the reason it stays the same is because I'm just replacing this 8 with a 16, so it's not going to change what the middle is. All right, how would changing the 8 to a 16 impact the standard deviation? Well, the standard deviation increases because 16 is far from the mean. Okay? All right, that is all I have for you. So we will go over questions and we will have a short quiz.